Hello, welcome back to Piers Rocks. Today I'm planning to get to the bottom of the problems I've had with this 2040 disk drive. If you've seen my previous videos on this 2040, you'll know that it does appear to be working, although it's been giving me some rather strange results. In the first video I had all sorts of problems, and they turned out to be as a result of me failing to initialize the two drive units before reading from them. I haven't confirmed it, but I'm fairly sure that this 2040 is running CBM DOS 1, and therefore you need to send an init command, an I followed by the drive unit number 0 or 1, to the drive to get it to initialize the drive before you attempt to read from it. In the second part, I serviced both of these two drive units, and then saw some rather strange behaviour when trying to use my Linux PC and XUM1541 with an IEEE 488 bus to access this disk drive. So that's going to be my main plan of attack for today, is using the Linux PC, OpenCBM and my XUM1541, which does expose the IEEE 488 bus to drive this disk drive. And you may notice that I've also got one of my 2031s at the ready. The reason I've got this one at the ready is so that I can run with two drives on the same bus, and I'm fairly confident that this 2031 is working as expected and runs DOS 2. The other reason for using this drive is it has jumpers inside, so I can jump it to be device 9. So the 2040 will sit at device 8 and the 2031 will sit at device 9. So I'll get it hooked up. I have both of the drives powered up next to me. They're daisy chained together and then connected to my Linux PC using IEEE 488. And the first thing I'm going to do is to see what OpenCBM thinks I've actually got connected. I think I've set the jumpers on this 2031 to be device 9. The 2040 should remain at the usual device 8. Okay, so we do correctly detect that the device 9 is a 2031. We're still getting the same weird detection information for the 2040 as we got in the last episode. So we're seeing unknown for the device type, and we're seeing footprint equal DNO at. And I was a little worried actually after last time's episode that OpenCBM had just got into a dodgy state, and that's why it was replying with this weird information. But actually, I think that my first thought is probably right, which is the ROM in this 2040 is old enough that OpenCBM doesn't properly detect it. From a quick squiz at the source code, the OpenCBM seems to be loading a couple of 2-byte sections from the ROM in the disk drive and using that to detect what model is actually at a particular device number. So next thing I'm going to do actually is I'm just going to quickly open up the 2040 and see what version ROM the 2040 has installed. As you can see, I've opened up the 2040. I've taken a photo of the ROMs, which I'll put on screen now, and they're 901, 468-06 and -07, both marked as 18th week of 1979. We'll take a look at the OpenCBM code now and the routine that is being used to actually detect the model and footprint of the drive. Figure out how that works, and then we'll download these exact ROMs from zimmers.net and see if we can understand why we're getting the weird identification information for this particular disk drive. Here's the identify function within OpenCBM, and we can see something very interesting immediately. This is obviously the string that we're seeing in the case of the 2040 disk drive, and this footprint is being populated with some information. We can also see this command, which is being sent down here in exec command to the disk drive, and I think this is doing a memory read, so reading from the memory of the disk drive. It's reading from memory address, I think these 2 bytes, FF40 with 6502. We have to flip the 2 bytes around. This is the high order byte and this is the low order byte, and we're saying read 2 bytes. We then put the disk drive into talk mode and we read 3 bytes, which is presumably the 2 bytes of data we've asked for and a terminator. Don't know what sort of terminator. We're then essentially treating that as a magic value, doing a bit of manipulation on that, which I haven't fully understood, and then switching based on that magic value and deciding we've got a 2031 or we've got a 1541 or whatever based on that. Now, there's no 2040 in here, which would explain why I'm not seeing 2040. We do see 3040, 4040, 8050, 8250, but we do not see 2040. So we're falling through into this default case in the switch statement. And then what this logic here is doing is it's taking magic, which is 16 bits, 2 bytes, and it's breaking it up into 4 bits, at a time, and it is, I think, ORing that information with 40 hex in order to make it visible ASCII, and then it's putting that in bytes 22 to 25 of the unknown device string, and that's what we're seeing coming back to us. If we go back to our detect string, then we're seeing unknown footprint equal DNO at. So we can figure out by taking 40 hex off that and basically reversing this logic exactly what bytes it's seeing. But there's an easier way than that. I'll just download the ROMs from Zimmer's and we'll open them up in a hex editor. Now we want the 07 ROM, which is the high ROM on this disk drive, because the high ROM is loaded into E000 and the low ROM into C000. That's assuming they're 8K ROMs. I can't remember if these are 8K ROMs or 4K ROMs, but it'll become pretty clear once I've downloaded the firmware from Zimmer's. So I've downloaded the 2 ROMs from Zimmer's. I was wrong, these are 4K ROMs, not 8K ROMs. So the high ROM starts at F000 and runs through to FF, 4 kilobytes long. So I want FF40, so in this file that would be at 0F40. I've got the hex editor open, so we go down to FF48 minus 4 bytes. So that is the magic string that we're looking at from this disk drive. So at this memory address, it loaded in 2 bytes. So F40, it loaded 2 bytes. Oh, which way around is it taking the bytes? So I don't actually know the order that the disk drive returns the information to us in, but I'm going to assume that it gives us the first byte first. So it gives us the byte at FF40 first, and then the byte at FF41. So buff 0 is going to be F0, and buff 1 is going to be 20. So it's shifting the 20 hex left or up 8 bits. So we end up with 20F0 at that location. Now we can run through and we can look at what it's doing based on that. It's going if magic equals AAAA, well, it's not AAA, or as well, if magic equals 01BA. So we can see if we've correctly identified the bytes by modifying OpenCBM and adding another case. So if I add the case of F020, device type. Now I think there is a device type of 2040, and I knew that prior to the last episode, which was why I was expecting OpenCBM to be able to detect this device type. Device string equals 2040, and we need a break in there. Okay, that's written. Okay, so I've tried to make OpenCBM, and of course I can't write C. I need a colon there and not a semicolon. Let's try compiling it again. Yeah, that looks good. And then let's reinstall, or let's install the new version. Linux, makefile, Let's just have a quick look, see whether it did indeed update the binaries. It is January the 10th and it is 1335. So CBM control was updated 1 minute ago. Excellent. And let's just check when we run CBM control, that is the version we're using. It is. Brilliant. So let's go back to our first shell. Let's rerun CBM control at this point. I've turned off the 2031 to avoid any overheating issues. But let's see if we can now detect the 2040. Seems to have hung. I find this is a fairly common OpenCBM problem. Could be a problem with the XUM1541 that I'm using. Let's just do a bus reset. Doesn't want to do that either. At this point, I'm going to unplug and replug the USB device. Right, the reset completed successfully. I just want to see if the disk drive, also the LEDs come on when I do that. Yeah, they do. Let's detect. So we're still getting unknown, so it looks like I haven't modified the code to do the right thing yet. Let's go back and have another look at the code. In order to avoid too much messing around, I've stuck a printf in the default case statement. And let's run CBM control detect. So we get a magic of 4EF0. I don't know why the function is being called twice by CBM control. One of those things, I guess. If we look in the ROM, so we're looking at the 07 ROM, the high ROM, and we search for 4E hex, it's not in the file. That suggests to me that the 2040, or at least the 2040 running DOS ROM, does not support the same set of commands for reading memory as the later DOS 2. So I need to get my manual out again and figure out what commands the 2040 is going to be prepared to accept. I'm getting somewhere. So I read the manual for the 2040 disk drive, which is here, and it documents the MR command, which is being sent to the disk drive. And the way it documents the MR command is you pass m-r, then you pass in a byte for the low order byte you want to read, and a byte for the high order byte that you want to read. It doesn't talk about you being able to then pass in a byte for the number of bytes you want to read from that address. So presumably that is an extension to the command that was added in DOS 2. Remember, I'm running DOS 1 on my disk drive. So what I've done is I've refactored the reading of the initial magic number to read it a byte at a time, which should work both on DOS 1 and DOS 2, given I'm expecting DOS 2 to be backwards compatible with DOS 1 and to support the MR without the number of bytes to be read at the end. Now, I've left this command as is because this command with these 2 bytes modified is being used later on if magic is a certain value to read something else to disambiguate between a number of different disk drives. And I've left that functionality in here. So if the magic number is AAAA, it's then doing another read to try and disambiguate. Same with 01BA. I've also got an added case in my switch statement for the 2040, which is here, and 20F0 were the values that we saw, F020 because it's flipped around, were the values we saw at FF40 in the DOS 1 image for the 2040. So I've compiled this. Let's run it to detect what disk drives we've got attached. Ta-da! We've got a 2040. It's correctly identifying the 2040 now, and it's still able to identify the 2031, which is running DOS 2. So that modified read memory command is working with DOS 2 as well. So very pleased with that. Now I've also had a look at the other ROMs that are available on Zimmers, and I wanted to see the values for those different ROMs. And they do, the values at FF40 for those different ROMs match up with these 2 values here. There are actually 2 different versions of DOS 2 available for the 2020, 2040, 3040 and 4040 drives. And the earlier DOS2 version uses this value, and the later DOS2 version uses this value. Now, I think I could upgrade this 2040 if I wanted to DOS2. The older DOS2 version requires two 4K ROMs, so I could replace these two in here. The newer version actually has a third ROM to be located at D000. Perhaps that's what this middle empty ROM socket is used for. And this later one is 20F8. So if I did that, this 2040 would identify as a 4040, which is probably right, because it's probably behaving exactly like a 4040 if it's got that later ROM installed. I didn't actually find on Zimmer's the ROM that has this string of F032. So I don't know where that's come from. Now, I've got a 3040 in the stack over there. I haven't tested it out yet, but when I do get around to testing it out, I'll see what ROM that has installed and whether it has this string, whether it identifies as 3040. So, really pleased to have got that identification function working. Now, having said all that, and spent a couple of hours on this so far, I'm not sure I'm any closer to actually getting this 2040 working with OpenCBM. I'm not at all convinced that this lack of identification was causing me any problems with using it previously. Maybe it was. Anyway, next step is for me to try doing some basic functionality on this disk drive with OpenCBM. I thought as the first test I should run with this drive, I should format a disk, because this disk drive is running DOS1. I don't have any other working DOS1 disk drives. I don't have any other DOS1 format disks to put into it. So first thing I want to get is a correctly DOS1 formatted disk. So that's the command I'm going to try and run here. Note, I'm not using either of the dedicated format commands that come with OpenCBM, because I'm guessing they're doing direct block level manipulation of the disk, and I've got no confidence that the commands that OpenCBM will be using will be compatible with DOS1. I am hoping that the CBM control command is compatible with DOS1. This is then sending the N0:2040 drive 0, AA string directly to the command channel of the disk drive, which should cause it to format the brand new floppy disk that I have inserted in drive 0. Let's give it a try. Well, that didn't work very well. The status LED is on, so I presumably have an error. Let's have a look at the status. Drive 8. 31 syntax error. It might be that I need to use capital letters. It might be that I need to pass in the PETSCI switch. Let me pass in the PETSCI switch. That's better. So if I'd used uppercase letters, the command would have worked initially. One other thing that's interesting to me here is when I did the status command, I got 31 syntax error 00 and then 31 syntax error. I don't know if that's because I'm getting a syntax error for the drive unit and then an overall syntax error from the entire device. It will be interesting to see once I have two disks loaded and I'm doing things with two disks simultaneously. When I do a status command, do I get two statuses, one for each drive? Do I get three, one for each drive and then one for the overall unit? So that sounds like it's finished. The status LED is not on, so it should have succeeded, but we will check the status. The status is I'm getting 3 OK statuses for the disk drive, so that's brilliant. Now we should try reading back the disk. I remember very well in DOS1 that you have to initialize a disk drive before you can read a disk inserted in it. I don't know if that's the case after you have formatted a disk, whether it's remembered the ID of the disk it's got inserted, but I shall be on the safe side and I shall fire in and initialize for this particular disk drive. this causes it to bump its heads against track 1 and then presumably go back to track 18 and read in the header for the disk. Now I should be able to run a dir for the disk. It's worth saying that I don't know with the dir command how it's doing the dir. I don't know if this is compatible with DOS1 commands, but I'll give it a go anyway. So I'm getting a read error, and that is a little bit of a surprise to me given I've just formatted the disk in this disk drive. Okay, so the initialize command claims to be working, but then the dir itself is failing. I'll try putting this disk in the other drive unit. And then initialize that drive. Status light came on. So it is reporting a read error. 20 is a different read error. Block header not found. The disk controller is unable to locate the header of the requested data block, caused by an illegal sector number or the header has been destroyed. So the physical media looks okay. I'll try format in this disk drive. That's completed. The status LED is not on. We're getting okay. We'll initialize that drive. Looks like it's done. Now let me do a dir. Still getting a read error. At this point, I'm wondering what happens when you do a dir in using this mechanism with a dual disk device, and whether the lack of a disk in one of the drives causes a problem with the dir. So I'm going to get a second new disk and I'm going to format that in drive 0 and then I'll do a dir. One thing that's just come back to me is a thought I had after filming the last video, which is I've not done a speed test of this disk drive, either of the drive units. So I don't know, I'm assuming this drive unit runs at 300 RPM like 1541, but I've no idea how close to 300 RPM we're getting and whether that could be causing us a problem. Anyway, the format is completed now on drive 0, so let us check the status. Looks good. Let's initialize drive 0. Let's initialize drive 1 as well. Done. Check our status. Yes. Now let's try doing a dir. What do you know? I get a successful response. Now I'm only seeing, let's just run that again for clarity, but I'm only seeing the directory listing from drive unit 1, not from drive unit 0, but we're getting a successful response. So I'm beginning to think that those DIRs that were failing weren't actually failing because it wasn't able to read the disk, but because it was trying to read both drive units and an error in one was causing an error for all. The other thing I'm a bit suspicious of is that I'm not sure that the OpenCBM status handling can properly handle multi-drive units. If you look at my shell, you'll see sometimes when I get 3 responses, I get 3 full responses, and I think that's for drive 0, drive 1, and the entire unit. Sometimes it's getting cut off, like here, or here, or here. I don't know if I'm supposed to be getting 3 responses up there or 2 responses, but I've been doing some other work with OpenCBM, and I've seen a bunch of cases where the status string is getting corrupt. So that's actually going to be another area of focus for me, checking the OpenCBM source code to see if I can figure out what is wrong with the status reporting. Because without sensible and accurate status reporting, it's a bit like chasing a needle embedded in a haystack in a haystack. That's a terrible analogy. There's better analogies, but I generally, when I'm trying to find problems in bits of software, if there's problems with the diagnostic mechanisms, I like to fix the diagnostic mechanisms before I continue tracking down the problem, because otherwise you can just be going round and round in circles. What you think is a problem turns out to be a problem with the diagnostics. So that's where I'm going next. Take a look at this. Every time I run CBM status, I lose another byte. Oh, and I've gone back to all of the status again, but I've got a blank line. And I've got some random stuff coming from the beginning again. So I'm pretty confident there's a bug in here somewhere. There are two parts where the bug could be. The first one is actually in the CBM device status function that retrieves the device status from the disk and passes it up to high level code. Or it could be in the CBM control function that is calling into that function. Let's take a look at the device status querying code. What we're looking at right now is the CBM device status function. This is in OpenCBM library that's used by various applications. And the way this works is the caller passes in a buffer of a certain length to this function, and this function populates it with the device status. And in case it can't read the device status, it pre-populates this value, this special OpenCBM error value, in the string, in the buffer. And at a first glance, I've skimmed through this, and it looks safe. All of the various operations that it's doing seems to be sensible. It is... First thing it's doing is it's sticking a 0 at the end of the buffer. Seems sensible. When it reads it in, well, when it copies its own value in, it's using strun copy, safer version of strun copy, so it's not going over the end of the buffer. When it reads it in, it's reading directly into the buffer, but it's reading in 1 byte less than the size left, so it's not overwriting that final null terminator. So it's all good. And then it's reading, it's turning the first however many bytes of the string, if it's decimal integers, into a integer value, so it can return that as the return code. Now, it's doing it, it's not doing it multiple times. That's an if statement, not a for loop. And that's just to check that we've not been given a null buffer and we've not been given a 0 length buffer. Okay, so that's CBM device status. What's calling that? Well, one of the big problems we were seeing was with CBM control status. That's in this file, which is cbmcontrol.c. So if we search for CBM device status, we'll find the doStatus function. This is what's being called when you run CBM control status, whatever your device number is. And it's calling CBM device status. Now, I've modified this function to increase the buffer size. It was originally set to 40 bytes. That's not long enough, I think, for this disk drive, because I think, I'm not sure, but I think this disk drive is returning a multi-line status. So I've increased that to 256. I've also increased it to 256 in the only other place in this file that's calling CBM device status, which is the dir function. Here we're in the directory, do directory function. And that's calling device status here and also lower down. So I changed buff from 40 to 256 here. And look what happened. Now when I run the status command, or presumably when I run a dir command, I get a massive long status string, repeated over and over and over again, and I don't understand why. So I've re-implemented CBM device status myself to give myself confidence that it's doing the right thing, and it hasn't changed anything. So when I run device status, I still essentially fill up the buffer that's passed in with the same status over and over again. So this makes me think that we're looking at another DOS1, DOS2 compatibility issue. Because if I do a status query of the 2031, I just get a single status line. So I think I was unfairly maligning OpenCBM in this instance. I think it's just another incompatibility with DOS1. What I'd like to do now is do a debug print of every byte that I'm receiving from the disk drive to see if there's any kind of non-printable character at the end of the actual string that I can use as a terminator and to decide we've received the entire string from the disk drive. That would certainly be easier than having to parse the string that we're actually receiving in CBM device status and then figuring out, yeah, we've seen 00 and OK, 00 and 00, and we've had the right number of commas and so on. That would be a massive pain to implement. So I've quickly added outputting all of the bytes that are received from the disk drive. This is querying from the 2031. So we're seeing 3030 hex, which is the 00. Yeah, we're seeing everything that we'd expect here. We're seeing an OD there. That's either a /R or a /N for a new line or carriage return. So let's see what we're receiving in the device 8 case. Obviously we're getting a lot more data because it's repeating over and over again. So we get 3030 2C, that's the comma, space, OK, comma, 00, comma, 00, new line, same thing over and over again. So that suggests to me that the only byte we can use as a terminator in this case is the 0D and stop reading at the 0D case. And we're going to have to read it byte by byte, or we're going to read too much. I think the reason why we sometimes see it starting at a dodgy place is we've just read 256 bytes, and that's finished at a 2C30, which is, what's that? Well, 30, so it's a comma 0. There you go, that comma 0 there. So when we read again, we're going to start from where we left off, which is the next 0. So yeah, we're going to have to read it byte by byte and build up the string that way, which is a bit of a pain, but I'll give that a go and see if that works. I now have a stably working version of CVM control status that works with both DOS1 and DOS2, as I suggested, by reading a byte at a time and then deciding it's done when it gets a 0D character. And I'll just, you can see in front of you it working, but I'll run it again. That's the 2031, and the 2040 works just fine. So now I think what I'll do is try running some commands on the 2040, and then I can reliably retrieve the status command from the disk drive. I'll start off with an initialization of drive 0 and drive 1. I need petscii before command. That's done. We'll check the status. It's fine. I1. Check the status. Brilliant. Looks good. Now let's try doing a DIR. So we are still just seeing the DIR from drive unit 1, and then we're getting the successful status message. So the next thing I need to do is figure out why we're only seeing a DIR from drive 1. So this is another example of RTFM. If we look at the help text for DIR, and you can look at help desk for a text for a particular command like this, we see this file spec option, which can be used to restrict the number of files. Wildcards are allowed, but drive limitations apply. If we look at the source code, this is in the do dir function in CBM control, we can see that command file name is being loaded with that extra argument. That's then being used to construct the load file that's passed to the disk drive. $, is a standard dir, and then command file name is being added after it if it's entered. So on the 2040, there you can use $0 to load the directory of this, and $1 to load the directory of this. I don't know if there's a $ command to read both directory listings. I'd kind of assumed that's what $, was for on these two drive units, but it may not be. So let's try reading drive 0. Device 8, drive 0. Comes on. We see 2040 drive 0, the disk we formatted in that drive, and it's still in that drive. And then 1, this drive activates, and we see the right disk. And we can actually see right at the beginning of the drive listing 0 for drive unit 0 and 1 for drive unit 1. So we are finally getting somewhere. I'm still a little confused. I've had a bit of a play around to see if I can persuade the dir command to show me the listing of both drives, and I can't. If I do a dir of 0, then I get 0 at the beginning of the drive listing and I get the right header. Similarly 1. If I just do a dir of 8, I get 0 at the beginning, but I get drive 1's disk information. I tried putting star and $, which should put those strings directly after the $, in the load command, and those give a similar weird behavior. Here I got a 0 followed by drive 1's information, and here I got 1 followed by drive 0's information. So I'm coming to the conclusion that there isn't a way using the standard load command of loading the directory for both drives in one go. And that's all that CBM control seems to be using for the dir command, is just the load $, and then whatever string you provided afterwards. There are, with basic 3.0 and 4.0 commands to read both simultaneously, like the directory command. I suspect under the covers they're actually doing a load and then a load of drive 0 and then drive 1, and then just outputting all the information in a single listing. I'm going to move on from here because I don't think that's relevant to me. What I'm going to try and do now is find a 2040 DOS1 demo disk and see if I can write those files to one of the disks in this disk drive. I found two demo disk images on Zimmers, 2040demo.lnx and 2040demo.d64. I have no idea what an LNX file is, and I have an engineer around fixing my phone line and internet at the moment, so I can't Google to find out. So I have no idea how I'd go about writing that format. The D64 I may be able to write on the 2040 if D64 copy, which is another command made available as part of OpenCBM, works on the 2040 disk drive, and I have no idea if it does. But we'll give it a go. We'll give it a go. So D64 copy. We're going to want some options for D64 copy, because in particular we need to use the -T original option. It may, if we don't specify that, it may attempt to use a faster, smarter mode to communicate with the disk drive and might break the disk drive. So that would be if it was using the auto mode. We need source and target. Source will be the file name, target will be device 8. Give it a go. D64 copy. Original. 2040, one of the two 2040 files, that one. So the copy has succeeded. No status light on the drive. So we'll just do a status command to double check. All looks okay. Now, while this has been copying, I've done two things. I've had a quick look at the D64 copy source code, and at the top we saw warning unknown drive assuming 1541. That's entirely expected. I've double checked the source code. It only knows about like the 1541 the 1571, 1570 and the 1581, and the 1581 is explicitly not supported. So that message is expected. However, there's a bigger issue, I think, lurking in this display that we can see. This looks entirely normal for a 1541 disk drive, but this is not a 1541 disk drive. The 2040 and the 3040, so the DOS1 drives, support a different number of sectors per track. They support 21 sectors for 1 to 17, just like the 4040, which I think is like the 1541. But while the 1541 and the 4040 support 19 sectors for track 18, 2040 and 3040 support 20. Now, 25 to 30 and 31 to 35 are the same, but tracks 18 to 24 have a different number of sectors than the 1541 and the 4040, and D64 copy seems to have copied the 4040 and 1541 number of sectors rather than the 2040 and 3040 number of sectors. So the question in my head is, does this D64 file actually contain 19 or 20 tracks for these, sectors for these tracks? Don't know. Is the 2040 going to be able to read this disk? I don't know. Let's find out. Now, first thing we'll need to do is we will need to send the initialize command for this drive, I'm sure, because I'm sure that D64 copy is using block writes. So the disk drive, the processor on the disk drive is going to have to reread the header to update itself with what's in the disk drive. You need drive number, device number. So that's initialized without an error. What happens if I do a dir of 80? We get a load of nonsense. And I would expect a load of nonsense if track 18 has the wrong number of sectors on it. Because track 18 is where the directory contents are stored. So this could be a problem. Now, maybe it's a problem with drive 0. Maybe it hasn't written the information it was given properly. But I'm not sure I can do anything about that because D64 copy doesn't allow me to configure which drive it's actually writing the files to. Now, actually looking at this output, there's one thing I can see that looks right, and that's the end of universal and the beginning of wedge. I think it's universal wedge. In any case, there will be a wedge, a DOS wedge, on this disk that can be loaded by a pet computer, but we're not seeing that. I'm going to take a quick look at the D64 copy source code to see if there's any way of persuading it that there are a different number of sectors per track, particularly for the 18 to 24 range. The other thing I'd like to do is analyze the contents of this D64 file I have and see if it has the right number of sectors for those tracks. And then also figure out what on earth a .lnx file is and whether I have any hope of writing an lnx file. Right, I've tried a few things. I hacked D64 copy, where it has in the source code, I may be able to show you the source code. This array, which lists the total number of sectors for each track, and these were all set to 19. I set them to 20, and then I tried writing the file. Now, I'm pretty confident this hasn't worked because I think the D64 file format actually assumes 19 tracks, 19 sectors for track 18 through to 24. And therefore I hit a problem at the end of track 35, the last track on the disk, where the last 7 sectors were not written properly. Seemed to get a read error. Well, the number of sectors that I stole by taking an extra sector for each of 18 through 24 is 7. So I think D64 just has the number of sectors that it has within it, and it's faithfully laid them out as I asked them to lay it out. But I'm pretty confident that the DIR of this disk is not going to work. It won't have written in a compatible way. I'm a bit surprised that this 2040 demo disk came in a D64 format, if that's incompatible with the 2040 at least running DOS1. I also had a quick look on Zimmers at what the 2040 demo.lnx file is, and it says requires a links 8017 pet to unlinks. So there's some words. I have no idea what it means. I don't have an 8017 pet, if that's a thing. So when I'm back online, I'll see if I can figure out how to unlinks the file, and then figure out how to actually write the file to my 2041 disk. In the meantime, just for funsies, let's try doing a DIR of this disk now we've got things laid out in entirely the wrong way. I need to initialize it first. Device 8. No error. Let's do a DIR. No, that looks pretty much the same to me. So I'm a bit stuck. I've got 2 avenues for exploration. One is the .lnx file, for which I need a links 8017 pet. The other one is, I believe there is a Linux Fuse file system for D64 files. That actually allows you to mount a D64 file as a native file system on Linux. If I can get that find that and get it working, then I should be able to mount the D64 I've got, and then I can use CBM copy to copy the files directly onto an already formatted disk on this 2040. That's probably going to be my first avenue of attack once my internet comes back up. So I thought of another way I can get a 2040 demo disk image on a 2040 DOS1 format disk, and that's to write the D64 file I have to the 2031, which uses the same file format as the 1541, same disk format as a 1541, and then I can do some CBM copies of files directly from this disk drive to this disk drive. So to run the D64 copy, we need the original switch, so it doesn't try to use any capabilities the 2031 doesn't support, and we will copy the 2040 demo file to device. This is device 9. The D64 copy claims to have completed successfully. Let's have a look at the disk. So that all looks good. Interestingly, it did not set the header of the disk. I'm guessing that wasn't set properly in the D64 file. So the formatted and ID of AA we can see was what I set the header of this disk to before running D64 copy. D64 copy needs a pre-formatted disk in the disk drive to work, at least with the original copy mode. Presumably because it's doing an initialize of the disk drive, and the initialize of the disk drive makes it try and read the header, and if the disk doesn't have a header, it will return a status error, and then D64 copy will barf. Anyway, I seem to have all the files on this disk, so now I should be able to copy that over onto one of the disks on my 2040. Right.
I'm about ready to cry. So I've been off banging my head against these disk drives for quite a while now, and I've reached some conclusions, and I think I've managed to get some of the files for the 2040 demo disk written on a 2040 format disk drive. Let me take you through the process. First of all, I tried to read all of the files from the 2040 disk that I wrote in my 2031 disk drive. I have those. I can show you what the list of files is. That's the list of files that I pulled off the disk, and I think it matches the list of files that's actually on the disk. But I was thinking about this, and I don't think this is a 2040 demo disk, despite the fact it's labelled as such on Zimmers. And the reason why I think that is because a 2040 format disk would be DOS1 format, and that would not be written as a D64 file. It just makes no sense because of the different number of sectors on tracks 18 to 24 than a D64 file format. I also looked at this and I saw there was an 8050 reference in one of the file names, copy to 8050. And I don't think that would be on an original 2040 DOS1 demo disk. It might be, but my guess is that this is actually a 4040 demo disk that's also compatible with 2040s and 3040s if they have the ROM upgrade. And if they have the ROM upgrade, then they're effectively, for all intents and purposes, 4040s and not 2040s. So I don't think I want to copy this set of files onto my 2040 demo disk on the 2040. So I figured out how to unlink the other image that I have. So I have this 2040 demo.lnx file, which is a links format, and it seems to be some compression format for Commodore machines, in particular the PET. Now there's a command called, or program called CBM convert, which is again available on Zimmers, and I've got what looks to be the latest version 2.1 now installed on here, and you can use that to unlinks and extract all of the files in the links file. So you just run CBM convert and then the file name, like that, when I can type it right. That then puts all the files in your current directory. Now I've done that in this directory, and we have a different set of files here. Similar, there's a bunch of overlap. I've not checked the checksums between some of the files. I'm having a quick look as I talk at the file sizes, and I can't see any files that are common between them. Let's have a look. Check disk, is that on both? Check disk 1014 1014. So let's do a checksum of that. So check disk and then checksum of the other version. So those are identical, those files. But if we look at the contents of this disk, some of the files look a bit odd and not the sorts of files I would expect to see on a Commodore 2040 demo disk, like Invaders. I'm presuming that's a Space Invaders game. Air Attack. I'm assuming that's another PET game. Robin.key01.user and Robin.discra.user. Those look like files that have been written to the disk by a person called Robin. So this is not an original DOS1 2040 demo disk, but I suspect this is much more likely to have come from an original 2040 DOS1 demo disk, and then the person who owned that had put a bunch of extra files on it, like Air Attack, like Invaders, like Crash, I'm guessing, as well. So to cut a long story short, I then copied, using my bash script, all of these files onto a disk on my 2040. I was using CBM copy, CBM write, they're the same command, to do this. And there's no way in that program that I found to specify which drive the files go to. So I just ran the command and wait and seed. So now let's have a look what's on the disks in this disk drive. And fingers crossed, they're actually going to deign to read. So we do a CBM control command. We're going to do an initialize of both drive units. So no status LED, we should be good. Now let's do a DIR of the 0 drive unit. Well, that's strange, no files on there. But there's only 427 blocks free instead of 670 blocks free, so that looks a bit odd. Now let's look at drive unit 1. Oh, well, look, there's all the files that I attempted to copy across. Now, there are some problems here. Some of the non-PRG files have PRG suffixes on this disk's image, so I'm not sure that I copied those files using the correct format in CBM copy. But it looks like the files are on this disk. Although we've got 660 blocks free, not 670, not 427. So we have more blocks free than we should do based on the number of files that we put on this disk. That's led me to believe that CBM write, CBM copy, is doing something that is not fully compatible with this disk drive, and therefore maybe the BAM hasn't been written properly on this disk drive. But I seem to have some files on this disk, and let's try reading one of the files back, and we will see if we get the same, what we get back the file that we're expecting with the contents that we're expecting. So let's do a CBM copy read original transfer mode from device 8, and we want check disk.prg. So my guess is we're getting file not found because we don't want the suffix. So now we get a read error. Read error 22. Data block not present. Normally when there's no disk or it's a corrupt disk, you'll get error 21. 21 is no sync character, so it can't find the sync character on that track to make sure that it can actually read everything else relative to that sync character. That makes sense if you've got an unformatted disk or a disk that's been formatted for another system. I've also been getting read 22 and I've been getting read error 20. Read error 20 is block header not found. So again, this is making me think that the problems I'm seeing are down to CBM copy, CBM write, the same program, not being compatible with this disk drive. So what I'm going to do at this point is I'm going to fire up the PET connected to both the 2040 and the 2031. We'll try reading some of these files from the disks that I've written on the 2040. And if we don't have any joy with that, then we'll try doing a copy of the disk from the 2031 over to the 2040 using one of the commands that's actually on the 2031 disk, you know, this 4040 demo disk, as I think it is. There should be a disk copy command in there that we can use. And once we've done that, we can then test out the disk that we've written in 2040 and see if that's readable. Right, let's try with the PET to access the disks on the 2040. We open the control channel. We will initialize drive 0. Status light is off. That's completed. The status light is on. We're getting a read error, 20 read error. Looks to be on track 16. Let's try a DIR of D0, which did claim to initialize successfully. Nothing. And a DIR of D1. Nothing. There we get a disk ID mismatch, which might be because we didn't
successfully initialize that drive. We'll just try to initialize it again. Status light has come on again. So we don't seem to be able to read either of these two drives, disks that are in the two drives on the 2040. So I verified that the PET cannot read either of the two disks in the 2040 that I formatted in the 2040 using OpenCBM and then copied files over to. So I've reformatted them, I've initialized both disks, and now I've tried doing a DIR. So we're seeing the DIR of drive 1 but not of drive 0. Okay, we get drive 0 if we explicitly specify it, and similarly drive 1. Those are the headers that I initialized the two disks with. Now in the 2031 I have what I think is a 4040 demo disk that I wrote using OpenCBM. So I can load the unit to unit copy program from device 9, the 2031. If I run that, copy from unit 9, I want to copy the 4040 demo disk, copy to unit 8, file name star, source drive 0, test drive 0. To be clear, there's more evidence here that this is not a 2040 DOS1 demo disk, because this file is dated the 1st of July 1980 and my 2040 dates from probably 1979. I'll come back hopefully when a copy is completed. It's now started writing to the 2040, so I'll come back when that write has either completed successfully or failed. The unit to unit copy seems to have succeeded. There are no status LEDs on either drive and they've stopped doing things. So now let's initialize drive 0 of the 2040 and then do a DIR. We have some files. Well, that's a good sign, isn't it? Let's try loading the performance test. I have a somewhat sticky F key. Now bear in mind, if this performance test was written expecting a DOS2 disk drive, it may be that the performance test fails with this 2040. Yeah, well there we go. I mean, that's pretty conclusive proof that this is a 4040 and an 8050 demo disk and not a 2041. We'll continue and we'll say that we are running with a 4040. And I'm going to remove the disk I just wrote to make sure it doesn't accidentally overwrite that. Insert scratch disks in both disk drives. I can do that. So the 4040 performance test has finished successfully on the 2040. So that's a decent bit of evidence suggesting that this 2040 is operating successfully. Working on this 2040 feels like 2 steps forward and 1 step backwards most of the time, but I think I made some real progress here. I've updated OpenCBM to be able to identify this DOS1 2040 and also to be able to retrieve the status of this disk drive. I've also conclusively proved, I think, that the 2040 D64 image up on zimmers.net is not a 2040 DOS1 image. It's a 4040 DOS2 test disk image. I've then taken the performance test for a 4040 off that disk image and I've successfully run it on this 2040. So all of that is pretty promising, but there's 3 things I'm a bit suspicious of. The first thing, you can see this disk drive is sitting open. It's actually been sitting open throughout all of the PET testing that I've been doing in the latter part of this episode. That's because after I started receiving those 20 and 22 read errors, I noticed that the top of the case was quite warm and I thought I would open it up and let the heat dissipate in case that was leading to some problems with the disk drive. I don't think it was, but it might have been. The second thing is I'm a little bit suspicious of the alignment and also possibly the speed of these two drive units, because I've not tested them in any way, and when I've done some formats of this disk and this disk unit and then swapped the disks over, I've not always been able to read them consistently in the other disk drive. So I need to find some way of doing a performance test and a speed test with this DOS1 disk drive. And then CBM copy. It claimed to be writing files to this disk drive, but I'm suspicious it was putting some of the data on this drive unit and some of the data on this drive unit, and that's why we were seeing the files appearing in the directory listing here, but the blocks free count going down on this disk, and then the PET couldn't read either of the two disks. So I'm going to need to dig into the CBM copy source code and figure out what's going on there, but not in this episode. I'm going to leave this one here and come back to those things in a future episode. If you enjoyed this episode, please do consider subscribing to the channel. Until next time, rock on.